Have you ever thought about the biggest game of hide and seek in the entire universe? It actually happens every single day, right over our heads. And today, we're going to solve this cosmic mystery together.
I mean, it's the greatest magic trick of all time, right? One minute, the sun is up there, big and bright, and the next, poof, it's gone! So where does it go? Does it hide behind the moon? Or maybe it just goes to sleep? Well, we are about to find out.
Okay, so to crack the case of the disappearing sun, we need to meet the two main characters in this story. And it all comes down to a really big secret, a secret spin. All right, first up, let's meet player number one, the sun. Now, the most important thing to get about the sun is that it's basically a giant, super powerful lamp just hanging out in space. And here's the real kicker, it doesn't really move around us. Nope, it pretty much just stays put, shining all the time. And that brings us to player number two, our amazing home, planet Earth. Just picture our planet as this massive ball. But it's not just floating there doing nothing. It is always, and I mean always, spinning. Kind of like a toy top that just never ever runs out of steam. You know, this non-stop spinning actually has a pretty cool scientific name. It's called rotation. So whenever you hear scientists talking about the Earth's rotation, all they're really saying is that our planet is doing its constant round-the-clock spinning thing. So our giant ball, the Earth, is spinning on an invisible line that goes right through its center, from the North Pole all the way down to the South Pole. We call this invisible line an axis. And that steady, constant spinning around the axis? Yup, you got it. That's rotation.
All right, we've met our two players, the giant lamp that is the sun and the spinning ball that is the Earth. Now it is time for the big aha moment. Let's put them together and solve this puzzle once and for all.
So let's just think about this for a second. What do you think happens when you have a ball that's spinning all the time and a super bright light that can only shine on it from one side? You got it. Whichever side of our Earth is facing that giant lamp, the sun, gets totally blasted with all that bright light. It's warmer, it's lit up, and we call this daytime. So when you're outside enjoying the sunshine, it's literally just because your part of the planet is pointing right at the sun. But don't forget, the Earth is always spinning. So as it turns, your part of the world eventually faces away from the sun. That side is now in the Earth's own shadow. It gets dark, it gets cooler, and we call that night. The sun didn't go anywhere. We just turned our back to it. So let's break it down one more time. Day is just when we're facing the sun, bathed in light. And night is when we've turned away and we're covered in our own shadow. It really is all about our position relative to that big, bright lamp. But hey, don't just take my word for it. Now it's your turn to be the scientist and see this whole thing in action with a couple of fun, easy experiments you can do right now. First up, the globe and flashlight experiment. It's super simple. Just find a dark room, grab a flashlight, could be your sun, and any kind of ball can be your Earth. Now, shine the light on the ball and slowly start to spin it. See that? One half is all lit up in day, while the other half is in the shadow of night. You're literally creating your own day and night cycle. How cool is that? Okay, for this next one, you don't even need a ball because you get to be the Earth. Just find a lamp in your house. That'll be your sun. Now stand to your facing the lamp. The whole front of your body is now in daytime. Now slowly spin around in a circle. Check it out. Now your back is having its day and your front is experiencing night. Awesome job, scientists. Now that you've seen it for yourself, let's lock in everything we've learned with a few rapid-fire fun facts. You ready? So how long does it take for the Earth to do one full spin, one complete rotation? Exactly 24 hours. And that's why our full day and night cycle adds up to, you guessed it, 24 hours. And get this, the Earth is always spinning. It never takes a holiday, it never pauses for a break. In fact, it's spinning at over 1,000 miles per hour at the equator. It's been doing this for billions of years, and it will keep right on spinning. And this little fact will totally change how you think about sunrises and sunsets. We always say the sun rises or sets, but it's not actually moving across our sky. It's us on our spinning Earth who are turning to face the sun in the morning and then turning away from it in the evening. Pretty wild, huh? And there you have it. The Great Disappearing Act is officially solved. The sun wasn't playing hide and seek after all. It never went anywhere. We were the ones doing all the turning the entire time. So we solved one mystery, but that kind of opens up a whole new can of worms, doesn't it? If our planet is constantly spinning at hundreds and hundreds of miles an hour, why don't we feel it? Why don't we all just get super dizzy and fly off into space? That sounds like a great question for another explainer. Thanks for joining us.